So if you do tail -f on warlock secure,
Yeah.
you will see what this thing is doing.
So it's the same process dot xze. The command is dot xzd
My
directory
messages?
scanning, and it's
Secure,
taking
secure.
1590.
Give me one second. Warlog secure. No, there's something funny going on. What is going on? So these are all the people trying to log in?
No, so this user, you see that user that is starting this process is trying to connect from our system to outside to some other systems.
Oh, I see. So the system is under attack, definitely.
Somebody from this machine, the user from this machine is trying to connect to outside.
Yeah. So can you disable the user?
Yeah, I'm just gonna kill this process basically.
Kill the process. This is, folks, take a look at this. This is how the cyber attacks take place. Take a look at this. This is beautiful. So somebody got access to our server and now they're going out to connect to other servers. Why did our server get attacked? Why did our server get hacked? Put it online. We said anybody can come and they can literally create an account, and by creating an account they will have an account on our machine. So, and the YouTube video is on the YouTube. So I knew this was going to happen, and this has happened many other times too. So imagine this user, somebody who got access to our server, they created an account. Now they're using that account to launch an attack on other machines. Take a look at this in bulks. So you see, right now you guys understand this beautifully. You understand this. How this is what's happening over here. So we are server 101. Somebody using SSH from our machine to connect to this machine, and it's getting failed. Okay. And meanwhile, some of you are logging in from your machines into this machine, and it's getting accepted. So while this is happening, because this is wild, he started a program. While this is happening, take a look at this. Our resources are going up and up. Take a look at this. You have probably never seen the load average going this high. You know what this means? This means the 18 CPUs in our server are 100% utilized. The top command is like a task manager. And take a look at this. The 18 CPUs in our look, we're seeing 26 CPUs right here. Out of the 32 CPUs, the 18 CPUs are 100% utilized. That's what this load average means. This means the server is under a lot of load. It's utilizing like 20 CPUs to the maximum. So there's no processing power left for us. Don't need to get scared. We are going to prepare you for this. I'm glad somebody did this, okay? I'm glad that this is happening. Now, why did this happen? It has happened so many times because we allowed it to happen. We put the Linoopt server on the DMZ zone. That means it's sitting on the internet. Then we allowed anybody to come and to create anybody to come into our server and to create a user account. So a hacker who wants to basically hack other machines got access to our server, and he's now launching the attack to other machines. How do we know this? Take a look at this. The server is getting unresponsive. How do we know this? Well, there is something called logs. We look into the logs and you see this. He's like massively, he has a program that he's running. What's the program name? If you run the top command, you will see the program name right over here. This right over here. .xz .xzdec xzdec. Okay. xz
Actually, is for compression or for some kind of backup.
No, that's just the name of the file he has created. The process.
Yeah, it's a malicious file that's running. Yeah.
Yeah, it's a malicious. Okay. Why he's doing this? Because he wants to use our server to launch attack on other machines. So this way, when the investigation takes place, it will be on us, right? If he's, let's say, if he's logging into, if he's launching an attack on some government institutions, FBI is going to come knock on my door, says, hey, we saw that your server was accessing, launching attack on multiple servers. And why is that? And then they're going to ask us, okay, give us the access to your server. And then we will give them the access. They will go through these logs. They will see what happened. And then they will clear us. Otherwise, this looks like we are launching an attack. I was waiting for this to happen one day because I knew the potential of making a server, putting it there 24/7, and leaving it just like that. All right, now, so how many of you understand what's going on over here? You have an idea, and you find this fascinating that you understand what is this happening over here. Even if you have a slight idea of what is happening over here by what I just explained to you, just take a look at this. I mean, during these 3 weeks or 4 weeks, you are now able to understand what I'm talking about. What is his purpose? Well, he probably wants to get access to a bunch of servers and launch, maybe steal identities, maybe steal data. Our server has nothing. You have to understand one thing. Our server has nothing, right? There is no proprietary information. We don't have any information. We don't have any credit card numbers. But imagine if you're Amazon, if you're a Walmart, if you are a government entity, if you're a motor vehicle entity, any agency, you would have lots of customer data. Customer name, customer email address, customer social security number, their credit cards. So what they do is they steal this information from different servers. Remember, Target, Walmart, Amazon, they all have their servers online, and that's how you go and buy things from them. And while you're buying your things, you have your credit card information over there too, right? It's sitting on a server somewhere, right? So if a hacker can get access to that, okay, understand this. If a hacker can get access to that, they steal your name, they steal your information, they steal your credit card information, and they go and they sell it on the dark web. They go and sell it on the dark web somewhere. There's always a buyer over there. There's like a bunch of websites where you can do illegal activities and you can hide your identity. So sellers go there to sell credit card information. Buyers go there to buy that credit card information. And also some of these people, by the way, these TikTokers, right, especially from South Asia, you know what they do, these TikTokers? Their gifters usually use the stolen the stolen credit cards to buy gifts from TikTok, and then they send it back to the person that they're affiliated with, the live chats that goes on there, and they're throwing the rose and whatever the terminologies they have. Yeah. So they are basically taking this money, which is black money, and they're basically converting it into the white money. That's called money laundering. Do you understand what I'm telling you? This is how some of these people in Pakistan, they get so rich. And in India, in Dubai, these scams are taking place. You don't understand what I'm talking about? I'm not going to give any names over here. So the hackers get access to your information from these websites. How many of you in the past have gotten a letter from a company that you dealt with? Target, Walmart, CVS, Walgreen, any retail, and they sent you a letter saying, we are sorry to inform you that our server was, your information was stolen from our server. Unauthorized access. LinkedIn, YouTube, we all have been there. And if it's a financial institute like a credit card or a Target or Walmart or Amazon, then they offer you to sign up for a service that will monitor your credit for maybe 1 year or 2 years. Okay. Now, also, by the way, those of you who are Vikram, this doesn't mean anything right now. Take a look at this. He could name the file anything. Okay. Now, another thing is, any luck, Nasir, or you want to reboot the server?
Oh, no, so you can continue. Oh, we have commented out everything. Don't worry. You can continue to work. We have stopped their jobs. We're
Well, why the load average is 18%? I mean,
I just stopped the cron dem. Just give it some time.
if there was a cron job,
Yeah, it's still there. Yeah, it's continuously sending out mail outbound.
is it sending out the mail as well as the connections?
Yes, SSH connections as well.
Okay, so I think the best thing to do would be to reboot and clean out everything. But investigate.
Yeah, just come on.
Maybe they will leave the footprint over there. Take a look at this. The CPU spike. So one of the top-notch command. While we're at this, okay, this is interesting that this is happening today. I'm going to explain you something over here. This is beautiful. I love this. This is great that I get to teach you this. Take a look at this. Now the CPU is going down. Take a look at this. The load average is going down. And pay attention, the load average is going down. What I'm looking at over here is I am looking at all of my CPUs and their utilization. This is beautiful. Take a look at this. Now that Nasser has terminated his process, the program that this malicious hacker was running on our server, the load on the server is going down. You see this? In real time. The load on the server is going down. Now only 9 CPUs are 100% used. Before it was 17, 19. Now only 9 CPUs out of 32 CPUs were 100% utilized. Now imagine if we had just 2 CPUs, what would have happened to the server? It would have crashed. You know what crash basically means? It means it wouldn't be able to process any more instructions. The process would get queued and the server is busy. Nobody can log in. Nobody can run any command. It would just hang. Remember when I was running my command, it was just hanging. It was just hanging. So this is amazing stuff. Look over here. Now the load average has calmed down. Ladies and gentlemen, we were under the cyber attack. Congratulations to all of you guys. Okay. Now, if this was a Walmart or Amazon or any other company that you work with on maybe YouTube, Google, Spotify, if they have your information, if they have your credit card information, they could have gotten away with your information. That's why you always need to monitor your credit report. Is a server that only uses low amount of CPU even worth hacking? It's not about what the server capacity is. It's about what the server is worth, what the server is holding. When the hacker came into this machine, he specifically looked for the private information, the some of the information, but we don't have any information on the server. We have no information on the server. Furthermore, what we did was basically, because we know we put this server on the internet, usually servers don't sit on the internet. I mean, they do. They're called PCI servers, the ones who do transactions for, where you guys go and log in. And so there are ways to protect your data, but I'm not going to get into this right now. Okay. The server is public. Our server is public, but it's segregated from our other network. Imagine if I were on that network and if the server also had access to my laptop, the first thing the hacker would have done is basically get into the server. From this server, get into the network of that home network. And if there's any laptop, if there's any Wi-Fi, if there's anything connected, the hacker would have been able to get into that machine. Now, if he got access to my machine, my credit card information is saved over there. And then he would have gotten away with my credit card information. And then he would have sold it onto the dark web. And then he would have, somebody would have bought that credit card information. They sell it in bulks, 50 credit card, maybe for $10. That's how they make money. And then somebody would have taken the credit card information, which includes the credit card number, the expiration, banking information, the router number, the account number, the address. The meeting ended, in my opinion, because I think my network may be having a problem, a little hiccup. And because of that, because I was the host, every time if there's a hiccup in my network, meaning if my network drops for 1 minute or for 1 second, it would kill the session for everybody. I think that's the best explanation I can give you for the Zoom meeting. And because I have a 20 years old kid who understands these things, he's a certified, sometimes he decides to do crazy things, He's downloading a large file or he's, trying some program on his end, and so we always have this conflict, and ever since he was like 13 years old or 12 years old, he's been doing this, and I have to yell at him. But it made him super good playing with this stuff, He's able to land a $140,000 job. A 22 years old kid. Hats off to him, mashallah. Hats off to him. So it's about guidance for your children and also motivating them. It's not easy to be a parent these days, to be honest. Tell you that much. Anyway, now that we have things calmed down, look at this. The load average is 1.51. Now, 15 minutes ago, it was 12.46. That means 12 CPUs were 100% used. Do you guys understand this mechanism? I want you to understand the load average over here for 1 second. If you, folks, how many people out there You only need to ask them one question. Why the server is slow? How do you troubleshoot a slow server? Slow server. And this is a one question that the interviewer asks you. It's all about your resources, CPU, RAM, and hard drive. How many CPUs we have? 32. How much RAM we have? How much RAM we have in our server? I want you guys to give me the command to check the RAM over here. That's why I stress on this command, lscpu free-h lsblk. Okay. Now, imagine somebody wrote the program or malicious program, or somebody, it doesn't have to be a malicious program. Somebody wrote a program that eventually started using all of your 32 CPUs. In our case, it was 19 CPUs at a 100% utilization. That means out of your 32 CPUs, 19 were 100% utilized. So that leaves you around 13 available CPUs. And so guess what? The server is going to be busy processing because 13 CPUs are just sitting. 2019, 20 CPUs were maxed out. They were being used. Another thing over here, we have a 32 GB RAM. Now imagine when I was looking at that, the RAM, one program was using 15 gigabyte of RAM. So the RAM was 32 gigabyte was maximized, meaning that program, the malicious program, was using all of the RAM available and the 19 CPUs. When your server utilizes all of the RAM to the 100% utilization, what does that means? Well, this is your brain. This is your memory, just like you have a memory. If your memory is full and you cannot recall things, can somebody talk to you? Absolutely no. If you don't have your short-term memory, if you don't have your long-term memory, nobody can talk to you. That means you're useless man or woman. You're no use. Nobody can communicate with you. So your resources, are not intact. Your brain is your CPU. Your memory is your RAM. If your brain is busy, you're talking to one person, your brain is busy. That's a one CPU. Okay, I'm doing this. I'm talking to you guys. My one CPU, which is my one brain, is busy right now. I can't even look over there. I can't even see over there. I can't do anything. Same thing, the memory, which is given to you in your brain. Okay, if your memory is full, like you are overwhelmed, you're getting so much information and the memory is utilizing and you don't have a capacity to memorize more things, then nobody can have a conversation with you. You're useless. You're busy. You're basically overutilized. So when the server is overutilized or maximum utilized, then basically no more users can log in. And if you have a website running on that server, it's not going to work. Anything else that you have on that server or any program or application, it's going to stop working because your server is overutilized by something else. Okay. So is it possible that this kind of attack damage the hardware? No, it cannot damage the hardware. Okay. And somebody's asking me what time is the break time. Well, let's take a break over here, even though I cannot do the networking part because their VMs are not ready. And this is going to be the waste of time to do something which most of the students cannot follow. We have taken care of the navigating the file system. Okay. Nasser bhai, if you could help me today to give some more command in the file system, such as the cat command, and the touch we already did, and maybe redirection sign.
Yeah, sure.
And the other thing that you can do, if you have time, otherwise I
Yeah,
can also jump in.
sure.
The other thing that I can do today is, do you have access to your AWS client?
I do. I have access to AWS.
Okay. I would want to show them how to create the EC2 instance and a little bit about the concept of the instances. What are they? And then give them a little walkthrough on different services that they use in this.
Okay, that's
Okay.
perfect.
I think that should be good for today. And
I think that's a great idea.
so also some of the users are asking interesting question. They're asking, what did you do to resolve the issue with hacker? So
Yeah,
this is something that you're going to talk about.
sure.
How did you figure out that the server was under attack? Okay, and keep it at the very, very high level.
Higher. Right. Of course.
Explain the concept of logs and what
G.
they do for us, and then show some log events and the steps that you have taken to stop the program.
Okay, perfect.
Okay. Well, I'm going to take a question over here and I'm going to give you the class today because I think they need to see your teaching style as well. And I'm going to step away from this. So you are in
Okay.
charge today.
And we're going to go ahead and get rolling on this. Right. I hope you guys are able to see my screen. Yes, New York has its own. Nobody can beat New York. You know, New York is the greatest city in the world. Not because I lived there or you guys live there, it's because it has everything that the world needs. Unfortunately, they can't see New York as an example and live in cohesiveness and just, just be congenial. Anyway, so with that being said, I hope everybody is logged into the mobile to the Linux system, Linoopt server, and we're going to build on top of what we have now. Of course, first thing that we need to understand is that uh, let me pull up my good friend Paint. First thing that we need to understand is that Linux will be there will be a lot of files. Everything in Linux is a file. You know, anything, any user that you create, it will be in a.
I'm going
Yes,
to
sir.
interrupt you for 1 second, Nasir bhai. If you can quickly give us the background to what was happening to the server, because I'm reading your message in the group now. It's very interesting
Sure.
story that developed this earlier this afternoon. What happened? How did you resolve it? Overview of that, please.
Sure. So that was a really interesting scenario. So what happened was that a user had what happened was that so this is our Linux system, right? And you guys are here in your home. So somebody with the name of user, what they did was they connected to our system, and what they did was they created some. Now in Linux system, there are ways so that you can execute some commands or execute some jobs, commands, jobs, scripts, programs. They kind of are similar. So they were running a program which was on our Linux system, which actually which used some of the Linux functionality. And what that did was it basically exfiltrated to the internet. You know, it sent out emails, or it sent out, it tried to connect to other systems. So our system, the Noob system, was being used to, connect with the outer world, to the internet, as we would call it. So in essence, whoever was responding back, they would respond back to this system, our Linoopt system. Okay. And who would they see as getting call from or connection from? That would be from Linoopt server. And of course, Linoopt, the server has an IP address. And if ever somebody wanted to see who's trying to make all these connections, and these connections could happen at the speed of a second, or at hundreds of connections in every minute. So this is also, they call this, you may have heard of uh, spoofing. The word spoofing, that means that you are assuming someone's identity, and you are using those that device or that IP address to make those connections. So now when somebody would really respond back, they are actually responding to those requests those are coming from that specific IP address. Now, what could happen in that case is, if the connection requests are excessive and the response is coming back heavily from the outside world, well, then this system, it can end up getting crashed because it cannot tolerate all those requests. There will be overwhelming number of requests that are responding back. Think of it this way: those of you, you know, you heard of the term wedding crashers or the party crashers, right? So you invite a friend, he or she comes to your party, but you invited one person, but then they bring along 15 other people. Now, guess what? Your party's ruined now because there's so many mouths to feed. There's so many people, and they all have different. So, in that analogy, when your system is going to respond to hundreds of machines outside, and they're going to respond back to those connection requests, your system is going to go wild, is going to give up, it may end up crashing. But in our case, it was sending emails. It was and then also there was as I mentioned, on Linux, there is a mechanism through which you can schedule some jobs. So you can, maybe, if let's just say, if I want to create a file or a directory, let's say at 2 a.m., maybe it's needed, maybe for some project. So how can I make that job at 2 a.m. when I'm going to be sleeping? So for that, is a mechanism on Linux in which you say, hey, at 2 a.m., create a file, or whatever the command or the program, whatever you want to do. It is going to do that at 2 a.m. while you're sleeping. It's automatically going to do that. So what this gentleman or this user or was trying to do was, they were also using that mechanism. It's called cron. Don't need to worry about that. We're going to go over this uh multiple times, and you guys will know cron. It's basically a software. It's a program on Linux that you use. It basically does the task for you. You tell it, you schedule it, and it is going to, it's kind of like the alarm that we have on our phone. We tell it, hey, wake me up at 7 a.m., and it starts going off, and you wake up at 7 a.m. So same thing, cron is a scheduled task. So basically in that, you specify what to do at what time. It is going to go ahead and continue to do that. So but this becomes an art. So you can manipulate this. You can create a job, or you can create a task that executes every second. So you could imagine, if in 60 seconds it executes 60 of these tasks, you could imagine how many tasks or jobs or emails or messages that's going to send out throughout a whole day. And it's somebody's trying to abuse that system for their own advantage. We will come to learn. So some of the steps I did was, I turned off the cron. It's a program, so I stopped that. I had listed down what I basically did here was that just some of the steps that so that, of course, you are going to learn all of this, but some of the things that I did was, I took out that user. It was the user that was sending the emails or messages or all that stuff, or running any programs. What I did was, I added them into a file called cron.deny, so they would not have access to cron, so they can schedule tasks. I stopped that service so that they cannot leverage that service. Not only him, throughout the board, nobody's able to use that. Then I deleted all the scheduled jobs that the user had. I killed all the processes that this user was using. Maybe they were using shell, maybe they were running commands, maybe they were creating files. So I disabled the user to be able to log in, so he or she would not be able to get into the system. I gave them a shell which says no login, as you can see right here. We will learn about this. Again, these are technical terms. I know it may fly over your head at the moment. And then also, I deleted all their files that or assigned by helped me do that. He deleted all the files that were across the system, deleted, distributed by this user, and we used find command for that. And then we saw Amir Bhai listed all the processes. The processes, what it was doing, what this process was doing. He listed all the files that this process kept open. He deleted. These are all technical terms. I know right now it may not make sense to you, but slowly, gradually, we are going to build this understanding, and it would become just like a very, very, very known territory for you. Okay. And then we also deleted their cron jobs. Any of their cron jobs, we also stopped their emails. um, and then that's it. That's the stuff that we were able to do. And this is exactly, and these steps that we took today to mitigate that, these were the very steps that were taught to us in our RHCSA certification. And we leverage that understanding to secure our system. So, and then also some of the things, how were we able to assess what was happening? We were able to take a look inside of the logs. Now, logs are basically.
So tell them about the command tail while you can right now. Cat, tail,
Sure.
head, more or less.
Sure.
Yes, start off with reading the files.
So tail command. Linux has some funny commands. If you start imagining them, what these commands are, what they do, then it would make sense to you. For instance, tail. I mean, we know what it's not devil's tail, but it's tail like every animal, every pet has a tail. So that is usually their end, the bottom, the very low, So let's just say if this is a file, this is their head, right? This is the head, and this is the tail. I'm sorry, I'm using a mouse. So if you say tail, just from the word itself, where do you think is going to start reading the file from? Is it going to start from top, or is it going to start from the bottom? The word tail, it's going to start from the bottom. So when we are saying tail, that means, hey, show me the last lines. So remember, every file, when we write into it, we start from the top and we go at the bottom. So the latest entries, latest logs, they get added to a file, they are always at the bottom, right? Like right here, the latest logs are at the bottom. So when we say tail, that means, hey, show me the latest logs. Show me the latest lines in that, or the bottom lines in the file. So tail command is effectively doing that. But so for instance, if there's a file called /etc password. This is a file. If I want to see the last 10 lines, I would say tail /etc password, and I hit enter. It is going to show me the last 10 lines. Okay. Any file you can do that. You can do tail /etc, let's say group file. It is going to show you the last 10 lines. These are the last 10 lines. These are not from the top. Please, you have to understand which command you use. Okay. So these are the commands that it's showing you from the, but the problem with this tail command is it's reading from the bottom up. Okay. And then it reads, it spits out the stuff, and then it stops. It just gives me 10 lines, and then that's it. That's what it does. But tail can also give us a wonderful thing that it can follow a file for any new entries. These are also called real-time entries. You have this, we know that this file /etc, war log secure. This file, if I do tail on this, tail, it is simply going to give me last 10 lines. But what if I want to continue to see what is being added to this file in real time? What is happening, like, the real time input into this file? So for that, I can tell the tail command -f, hey, tail command, please follow it. Don't just give me 10 lines. Continue to monitor this file and show me what are the real-time updates. And when I hit enter tail-f, watch, you will continue to see people logging in. You see that new logs are being added. This is called real-time input. So the file is getting updated in real time. You see how somebody's logging in, Suleiman is logging in, session closed for Suleiman, connection closed by remote host, then invalid user, guest, okay, logging in from this IP address on this port, authentication for failure for, so do you see what is happening? Session open for user 10E1. All right. So tail command. What is tail? Okay. So tail command, as I mentioned, tail command, it reads a file from bottom to up. Okay. It reads a file from bottom to up. Now, those of you, if you think if there's a tail command, could there be an opposite of tail command? Could we have an opposite of? Okay, there you go. So the head command starts from the top and goes to the bottom. Okay, that's for head command. And this is a tail command. Okay, so tail command starts from the bottom and reads from the if. So because each file, every file has for lines in it, sequence of lines, data, or whichever way it has. So you could either read from top to bottom, or you could read from bottom to top. You just have to understand that's what tail command. So tail command start from bottom and reads from the tail of. If you were to picture let's just say an animal or a pet, a dog, tail is their most behind part, right? That's the end of them. So it's in that respect, tail is like the end of a file. You're starting from the very end of it and reading, to the front of it. And when you do head, it starts from the top and goes to the back. So if you did head /etc password, it will show you the very first 10 lines. If you did tail, and then the file that you want to read, let's say /etc/password, it is going to show you the last 10 lines. So head and tail. Okay. So they are, they're polar opposites, right? But if you want to see something from the very top, you can do that. If you want to see something from the very bottom, you will use this. But the good thing about the tail is, obviously, when a file is created, you are not going to write the latest entries, updates on the top. They are always going to be at the bottom. That's how, the natural rule of writing is, right? The latest stuff, unless you are doing in a specific, in a special or a specific, case. But normally we start from the top and then we go at the bottom. That's how it is. So with that idea in mind, if you want to read something from the bottom, you would use tail. If you want to read from top to bottom, you would use head, H for head. All right. So that's in simple, tail and head. These are the two commands to read a file. So if you want to read a file, let's just say you can do head /etc hosts. So what is the number of lines that is going to show you if you use head command, folks? The number of lines, 10. Yeah, so we only see 2. Should it have not shown us 10? But of course, if a file has only 2 lines, where would it get the rest of the 8 lines from? So if it only has 2 lines in there, then obviously it is going to show us 2 lines. And if you did the head on /etc password, which is a larger file, which has more than 10 lines, obviously then it's going to give us the first 10 lines. And same thing with the tail command. If you want to read the last 10 lines, you can do etc tail /etc password. So we know that there's a root file system that has an etc directory in it. Within that, there is a file called password. So now, if I didn't give anything to this tail command, folks, if I simply said tail and did not provide a argument, the word we use is argument. If we didn't do that, the tail command is just going to be like, okay. And you're going to be like, oh, my command is stuck now. Okay. The commands are meant to be used against something. So if you don't give them that, then you're going to get panic. You're like, oh, I typed the head command but now I'm stuck. But because you need to understand that the head command has to work against something, so I need to provide it a file, etc password or etc hosts. And that is going, same thing you can do with the tail command. Okay. Tail, and then the file name. So tail command is starting from the bottom and heading upwards, and head command is starting from the top and going southwards or downwards. Everybody good? Anybody lost or confused on that? I think it's a straight, can't see your screen. You guys are not able to see my screen, folks? Yeah, I think you guys can. If you are facing any issue with not being able to see my screen, you probably would have to change your view, folks. There's a gallery option there. I think you guys can go ahead and use that. Thank you. Okay, perfect. All right, awesome. All right, we're good with tail. I'm just calling because I am on phone. Okay, okay. All right, no worries. All right, so tail and head. Everybody with me? Everybody got that? It's as simple as that. Can you please talk about war log messages? Yes, I am going to go ahead and talk about that too. All right, good. So so far we did tail, we did head. Now the traditional command, the most, the way you would use to read a file would be through cat. The command is cat, which is basically shortened for concatenate. But cat is easier, so they say cat a file. And if you do cat/etc/password. Now, one thing I want you to pay attention to, folks, is when you do cat, it reads the whole file in one shot and displays the output on the screen. Whereas when you do tail or head, it just reads it partially. I mean, you can always increase and decrease the line number that a tail or head uses, but tail command doesn't read the file entirely. You can make it read entire file, but by default, by nature, tail or head only reads it partially. It only reads tail reads the last 10 lines, head reads the first 10 lines. But if you use the cat command, it reads the whole file itself. If you do cat/etc/password, now the problem thing is going to happen is that because it's going to read the whole file, my whole screen would get flooded with the output of the file. So if I hit enter, you see this? It read from the very last line all the way up to the very first line. So it reads the file holistically right here. So cat command is used to read a whole file. I mean, read the file entirely. Tail and head are used to read the files partially. Okay, so can we use cat command, and then once we are in the file, we use G command to read the last? Yes, you can do that. We are going to talk about that too. So what we can do is, if we say you want to read a file, partially. So let's just say we say head. What if I only want to see the first 2 lines rather than the 10 lines that head command shows by default? Well, I can say head and then etc password. But I can also say, hey, show me the first 2 lines. Okay. Oh, by the way, some of you guys are using an option called n. Let me take this moment just to reiterate, folks. In Linux, there will be a command section. The very first will be the command, and then a command will have something called options or flags or switches. They are used interchangeably. Okay, same thing. So this is part of the command, and then there is argument. Okay, that argument, and looking at this, looking at this, folks, by, when you look at this, what is the command in this whole line? What is the command in this whole line? Head. Head is the command. What is the option or switch here in this whole command? -2. Okay, or actually N right here. You can use, yeah. These are the options. Okay. And what is the argument? etc password. Very good. Very good. Okay, we want, I know sometimes when we use these words like, oh, what's the argument? Then you guys, many people get confused. Let me do it one more time. So if the command is ls-l /tmp. So what is the command here, folks? The command is ls. What is the option or switch or the flag? -l. And what is the argument? /tmp. Okay, so this option is all going to be the part of the command. It alters the behavior of the command. Okay, so if I didn't use any switch or option with the command, for instance, if I use ls/tmp and I hit enter, it shows me information just by the names of the files or directories. But if I run the same command, if I do ls-l, now it's a different option or switch that I added to the command. What I'm telling this command to do is present me information in a different manner. So now the behavior of the command has been altered. So do you see the difference when you use options? Why options are important? Options help you gain a specific type of information. If you simply use the ls command and list a folder, it shows the name of folders, files, and whatnot. But if you use a switch with that, it can give you more than, what it usually does. It gives you the metadata, the permission, the owner, and all that good stuff. Are we good with the command, options, flag, switches, and arguments? Are we good with that, folks? Okay. I know this is very rudimentary. Many of you guys would be like, okay, well, we already went over this, but I really want this to be established right now. Because down the road, when I will be telling you, hey, what command did you provide, or what option or argument you provided to this command, you guys are gonna be like, okay, what is he talking about? I don't want this to sound like this is French or Chinese to you guys. Okay. All right. So far we said that cat. So there's a command called head, and you do etc password. It is going to show you the first 10 lines by default. But then I can add an option in head command and say, hey, show me the number, N for number. Show me the first 3 lines, N3. Show me the first 3 lines. Or if I don't want to use the N, I can simply say -3. It's going to show me the 3 lines. But yes, in this command, this is the command, this is the option or switch or flag, and this is the argument. All right. So now there's a tail command. I want to see the last 5 lines. Tail -f or N-f or F. You can use that. /etc password. It's going to show you.
Does the spaces does matter over in the command?
Yes, very important. That's right. Yes, of course, this is going to be your command. There's a space here and your options and then space. But what if I and to Signboy's point, if I did tail -n5/etc/password. All right. Now system is, if I hit enter here, no such file or directory, it is taking this as a file or a directory. System thinks, oh, you're trying to access a file or a directory, you're trying to do something with it. So the Linux system is smart as long as you give it a smart instructions. If you give it stupid instructions, it's going to act stupid. So we do need to tell the system, hey, the tail is the command, N-N5 is the options or flag, and /etc/password is the file that you will need you to execute against. Yes, so you got to have space. You got to tell the system what is what. It doesn't know what, what's doing. You can do cat/etc password, but if you remove the space, Now system doesn't know what is the command and what is the argument, and you hit enter, no such file or directory. It thinks you are trying to access a file or a directory, but our intention is not of that, so we need to add space in between. And now when you hit enter, obviously it's going to flood my the standard output. All right. So far we learned tail, and with tail there's a special option called F. And what does F stand for? It stands for to follow. It continues to follow a file. So if you do tail -F /var/log/messages, meaning the latest entries made into this file are going to be exhibited or shown on my terminal. If I hit enter and I just keep an eye out, you will see that there will be more entries made here if there were any logs were entered in this. Okay. Or if there you go, you see started mark boot successful, started daily cleanup, temporary directories, reached target path, all these new entries, new lines that were made on July 6th at 14th hour, and then at the 9th minute and 6th second. And this is just a timestamp. So you see how you're getting the real-time update, like what is actually happening there. So that's why we need to be able to understand the difference between the command and options, flags. So this is basically a combination, and then you have your arguments. Argument 1. By the way, there could be multiple arguments, okay? Okay, argument 2. For instance, I can say cat /etc hosts, and then at the same time I can say read let's just say slash what's etc hostname. So this is the command and this is the argument. First argument, this is second. So cat command is trying to read 2 files. That's what it's doing. I am telling the cat command, please read 2 files. Is there any command to get middle file? Yeah, we're going to learn that. We're going to learn that, but do understand that you can do multiple things with one command. Not every command can do that, but we will learn which command can potentially do what. All right. So cat, head, tail, and now there's another command that is called more. More. There's a more command. And what do you think is the opposite of more, folks? Just like head has an opposite of tail, what do you think more could have? Yes, there's a less command. Linux is funny that it forces you to think logically. If there's a husband command, what is the opposite command? Wife. Okay. Yeah, that's right. So if there is if there is a so it would, if there's a north command, then it would have a south command. So you're going to have that. Okay. So just from an analogy perspective. Okay. So there's a command called more. You can more /etc/password. You can use this to read a file. So far we've learned tail command can let you read files, less can let you read files, cat command can let you read files. There's a more command that if you hit enter, it lets you read file. And then if you hit space bar, so these commands like more or less, they're called pagers. That's right. Simba is absolutely right. Husband is only commanded. Okay. The poor servant is always there. Anyway, so more command. If you use a more command or less command, these are called pagers. They show you information in page by page manner. It's not like you're going through line by line. It's showing you information or reflecting information in page by page manner. So if you do more /etc password, and then if you hit enter, this is the first page of that file. If you hit space again, second page, space again, third page, space again, fourth page. So space will take you page by page information, okay? Depending on your, the size of the window that you have, it shows you information in page by page manner, all right? So more, now less command does the same thing. You do less /etc/password and hit enter, page by page manner. But less has little more functionalities. We will come to learn down the road. It's just not only a pager or a file reader. It does much more than that. It's a very powerful command. So is more. So far the commands to read a file that we have learned are cat, more, less, head, tail. These are the most common commands that you will use to read a file, folks. Okay. So please add these 4 commands to your tool belt so that if ever you were to read. Now, folks, please, if I say cat to a directory /etc, can I do that? Can I read a directory? Can you read a directory? Can you more or less a directory? No. Yeah, exactly. This is for reading files. Can you open a folder? Can you list a folder? Can you do ls on a folder? Yes, that's what you can do. You can list a folder to take a look inside of it. But when you try to cat it, it's going to complain, hey, this is a directory, it's not a file. So just keep that in mind, that you read files. But just like in life, you read files, you read what instruction it has, what content it has, but then you have etc. The folders is where you keep the files. All right, everybody good? Everybody on the same page? Anybody lost or confused about these commands? Cat, tail, head, more, less. All right. All right, very good. Everybody's beautiful eye. Okay, awesome, great. All right, folks. Now with that in mind, let's go ahead and learn about how to create some files. Okay. So the simplest thing, elaborate less again. So again, less has more functionality. We're going to learn about it, how we can utilize less. So does more, but less is the most common. It's the command that can read uh, archived files or compressed files. It has more functionality. We will come to see across like what less can do. Okay, because cat, tail, head, more, less, they are reading, the standard files, but then less has additional functionality that it can read even the compressed files, which cat, tail cannot do. Okay, so just add these commands. So now we're learning to work with files. So let's go ahead and create a file, folks. So the command to create a file, the standard command to create a file is touch. Yeah, you say touch, and then you give it a name of a file. You say touch. Let's say, can you explain control C? No. This control C, this thing that you see right here, this funny character, folks. Whenever I press control C, you're gonna see that I'm trying to cancel out. So if I type a command, I know this is going to error out. I don't want to run this command, which is going to cause some kind of issue. So I simply do control C and I go to the next line. Okay. I'm not typing any special characters, and simple control C, it is going to show you that. Okay. Can you explain control C? I'm trying to cancel out of that. Okay. All right. Everybody good? Control C. When you're typing a command and let's just say you typed a command, and you're not sure that you're about, what results is going to produce. So you don't want to execute it, because if you hit enter, you see it's going to give you an error. And what if this was a harmful command that was doing something, that was deleting something? I didn't want to execute it. I am not sure about it. So how do I cancel that? Well, either I could backspace erase it, but because sometimes our commands are full of command switches and arguments and multiple arguments, We don't want to go erasing it. It may take maybe like a second, but we rather just quit out of that and do Control C. So we wouldn't have to execute that. Okay. So Control C is your best friend. It's a good friend rather. All right. Control C is just like, how you get that when you try to create a folder on Windows or file in a Windows. And for instance, if I try to add something here, and if I try to quit, you see it says save, don't save, cancel. So it's kind of like, I'm not sure, so I'm canceling out of this. So any command that I've typed, are you sure you're gonna because if you hit enter, that is like you're sure you know what you're doing. But I am not sure, so I'm just gonna cancel out of that. Okay, that's what it is. All right. With that out of the mind, out of the way, sorry, not out of the mind, out of the way. So if we do command is touch, and you provide a path to a place where you can create the file. Okay. Yes, tab is a beautiful option. We will come to learn the usage of tab. So the command to create file is touch, and let's create a file called file1. Before everybody does that, everybody, please make sure where you are on the system. Type pwd. Make sure you guys are in your home directories. Okay. If you are not in your home directory, so for instance, if I su-to Linoop, all right, I am Linoop right now. So pwd, I need to be inside of my home directory. You guys need to be in /home/ Saim /home/ Mariam /home/ Atif Mushtaq /home/ whatever your username is, you need to be inside of /home/ here. So I am in my home directory. If you're not sure where you are on the system, all you do is simply type cd and hit enter. It is going to bring you inside of your home directory. So cd is that, when I don't know how many of you fly drones. My son, he loves to fly a drone. I initially had a lot of passion for drones. So when your drone is about to run out of the battery, it's running out of juice, it automatically comes back to the location where it took off from. So this CD is that, drone coming back home. So CD is that. When you hit CD, it takes you back to your home directory, which is your private space. This is your home. So Linux system is like it's like a building, like a shared building, where everybody has their apartments. Everyone has their apartment. So what Linoop does, this is Linoop's apartment. This is their private home directory, private space. This is Junior's. This is Avas private space. This is Mariam's. This is Atif's. So everybody has a private space. Linoop cannot go into Junior's. Juniors cannot go into Linoop's or any other user. You guys cannot. This is your private space right here, Linoop. In your case, whatever your username is. So whatever you do here in this place, it's your stuff. It's your private space. Nobody can, eavesdrop into it. So now, but what if so cd command itself brings you home. But if you do cd and you provided an argument, let's say monkey or something, then what system is going to do is it's going to try to take you inside of this folder. Cd command, by the way, what do you think C stands for? Change. What do you think D stands for? Directory. So changing directory. If you don't specify an argument to cd command, where do you think it's going to take you by default? What is the nature of cd command? It takes you back to your home directory. But if you say cd and you provided an argument, for instance, I said, hey, change directory to /tmp, well, where do you think I'm going to end up being? If I hit enter, look, my command prompt, it went from this tilde or tilde, which is the reflection or which basically equals to /home/ my workspace. Now my current working directory is tmp, and which command will I use to confirm where I am on the system? Of course, the command prompt shows me that, but what is the command to check my present working directory. There we go. All right, do we see that? So cd command is, but then I simply type cd and I end up being in my tilde, all right, in my home directory. That's where I am right now. Okay, folks, very good. So cd command is very powerful. Now, let's come to create a file. So the command is touch, and let's create in our home directories, and I assume everybody's in their home directory because I had requested everybody to type cd and hit enter so they could get to their private space. Now here we are going to use the command called touch, and let's create a file called, let's say file1, for instance, file1.txt. By the way, I may sound like a very babyish, very rudimentary, but of course, it's my wallahi. I know we all come from different backgrounds. I myself didn't know what this txt stood for. And Asadbhai had to take our time to tell me, txt stands for that this is a text file, plain text file, because Linux has different kinds of files. So that's why he said this is the suffix, or this is the extension. So this is the name of the file. This is the extension. Now, can I create a file without an extension, folks? Can I simply say touch file1? Can I do that? Yeah, I can do that. But to the naked eye, they won't know what type of file is this. So I'm going to make somebody's life easier. Life is always about making somebody's suffering. You want to reduce those. Neil deGrasse Tyson, one of his very motivational videos that I love. Neil deGrasse Tyson, he's a really cool astrophysicist. So he says the life is about reducing the sufferings of others. So if you can reduce anybody's complexity or anybody that is feeling difficulty in any way possible, why not? It's a good deed. So if I added .txt, and if a person who's not as tech savvy as you or me, or those who are aspiring to be, they will not know what this is. So by adding txt, anybody can understand, okay, this is basically a text file. Okay, so if I created a file, touch file2 dot, let's just say pi, what do you think that could be? Or maybe it's a Python script, or maybe it's a zip, maybe it's a zipped file. So we're trying to make people's life easier by adding some extensions to it. Okay, so this is a good deed. We should do that. Although many times I myself am a very lazy guy, so I simply do touch file2. I don't add the extension. We should. Okay. All right, folks. So touch file2.t. Well, we created file1 already. The file1 is created. How do I confirm if no, Linux is a black window. I don't know. I'm not sure whether if it's created or not. Yes, although the command ran successfully, how do I see it? ls. There it is. Okay. No, I would recommend using ls command, folks. Tree command is very powerful. Tree command is amazing command. I love it, But what if you don't have tree command? What are your native options? What tools do you have locally available that you can use to take a look at files? So you got to get used to using ls. Okay, ls. And how do I tell the ls to show me more information, show me the metadata of file1? What option or flag can I use with ls so I can display more information? ls-l. ls-l. There you go. So of course it's explaining me, hey, this is the name of the file. And how do we know this is a regular file or this is a directory? Of course I did touch it. We know that creates a file, not a directory. But what tells us that this is a file or a directory? The very first, on the very left, you will see either a dash or hyphen. By the way, folks, I didn't know this was called hyphen. I had to Google it. Hyphen or dash. I'm so used to using dash. And some people, they even call it slash. It's not slash, okay? This is dash, okay? Sometimes we will, use it interchangeably, but it's hyphen dash. So this reflects, or this shows that this is a regular file, okay? If this was a directory, I mean, the name can be deceptive, it could be deceiving, but we always make sure using the commands that this is a file or a directory. You will see a D here, D for directory, and dash for regular file. All right, very good. Thank you. All right, looks like you guys already have the hang of it. So ls-l, we see that we created a file 1. Now let's go ahead and create a directory. Okay, we created a file through using touch command. To create a directory, you would use the command mk for make, dir for dir, mkdir. Some people call it mkdir, some people call it mkdir, some people call it, whatever comes to your mind. But I know mk stands for make, dir stands for dir. Okay, so I do mkdir, and let's call it dir1. Or actually, let's call it world. This is a cool example. I use dir1. Okay, so now I have created a directory. What does total tell us? So basically, it is telling us that, this is the total equivalent, what we have on the term. Hold on, touch command and to create an empty file. Yes, it creates an empty dir. Okay, a dash is no, dash is this right here, the one next to 0, the key next to 0. If you use shift dash, that is going to be underscore. We don't want that. You guys are not able to hear my voice clearly, folks? Are you guys able?
It's
Okay.
clear.
Okay. So, yeah, I was getting a private message. Okay. All right. Okay. So mkdir makes directory. And of course, we need to give it an argument. So if you do ls-l, or I could have done ls, either way, one gives me less information. Of course, I should not go with the color, coding, although it is very common to see directories in blue. But it is always recommended that we should go with, we should always look at the information that is displayed by the commands. So, of course, we know dash means this is a regular file. We know D means this is a directory. Okay. So now now we have created a file using touch command, and we have created a directory using mkdir. Anybody lost or confused on the touch and mkdir? Do we need to revisit this? Do we understand these commands? Okay, it's as simple as that. If you want to create a file, you do touch file2.txt. If you want to create a directory, you do mkdir dir, or let's call it dir1. Okay, or whatever you want to call it. And now when you do ls-l, when you long list it, you know that you have created file2, and then you have created dir2. And how do you know they are directories? They are using the dash. You can see the D for directory, and you can also use, you can see that there's a dash. This is regular file. Also, there's a command called file. You're gonna have to need this command very frequently. File command. If you say file and then you do dir1, it is going to tell you that this is a directory. If you are, if you're not concerned about watching this additional metadata, this is called metadata. Data about data. If you're not concerned about seeing additional information or the metadata, you could use the file command. You can say file dir1, you can say file1.txt and hit enter. It is an empty text file. Okay, it's an empty text file. So there are many ways to identify whether this is a file or directory. So ls-l is your standard native tool. Okay, and file command is basically there to, just simply tell you whether this is a file or empty file or it's a directory. All right. Can you please explain -l dash L? This is what is this, folks? Is this an argument or this is a switch to ls command? Is this an argument or it's a switch? It's a flag. It's an option. It's a switch. Very good. Yeah. So this is not an argument. If I did ls-l/tmp or file1, now what is the argument here? This is the argument, right? This is the argument in this one. How many people think this is the argument? This is the switch. That's right. Thank you. This is the flag. This is the option. This is the argument right here. All right. So this is the command, and the command has a switch so that it can, or flag or option, and then it has an argument that is targeting. So if I hit enter, now it is actually showing me information about, it's not showing me information about this, because now I have said, hey, long list me. By the way, this -L stands for long listing. LS stands for listing, -L for long. So long listing. Exactly. So the argument is file one. But now look, when I said ls-l and then I provided a path or a name of a file, it specifically listed me that file. It didn't show me world or file2 or directory, because now I'm using ls-l against ls-l against a specific argument or specific file. Okay. But if I don't do that, if I do ls-l, it shows me everything. It shows me everything. And by the way, when I do ls-l and don't provide an argument, it's long listing me the content. Where do you think it's listing me the content of? Of which directory? Okay, is this home directory or is this my home directory? My personal space. It shows you, if I do enter and if I do pwd, it is showing me the long listing of the folder that I am in. If I cd to /tmp, and now if I do ls-l, where do you think this is showing me the is going to show me the long listing of? Is it going to show me the long listing of my space that I was in before, or the place that I am in now? Exactly. So you got to keep in mind, folks, you got to be very careful. Sometimes, so let me go back to my home directory using cd command. It takes me back to my private space. So sometimes when you will do ls-l and you hit enter, you're going to think, oh, I am in TMP and this is the output of TMP. I am in /etc and this is the output of etc. No, it's not. No, it's not. You got to make sure where you are. Okay. So if I go to etc now, and now if I do ls-l, I see all this content. How do I validate where I am? pwd. Always do that. Always do that, because because of these commands and this newer landscape, you guys are gonna fumble. You guys are gonna trip. So it's always better to confirm. And by the way, you're gonna need execute these commands so frequently that it is going to get embedded into your brain. And at night times when you'll go to sleep, you guys are gonna start having dreams. Okay, dreams of commands, by the way. Okay, so I hope we understand this part so far. We used cat command to read a file. We used more command to read a file. We used less command. We used tail. We used head. And right now we used, I'm going to control C. So don't get amazed by this character you see right here. Okay. Disregard it. This is simply canceling out of a command. The next one we did was touch, and we did mkdir. Okay. All right. All right,
So
folks.
while you are a Linux user, can you create a file under slash under the file system?
That's a beautiful scenario you brought up, Signby. Thank you. Now, one thing that if you do ls / the mother root file system. This is the mother root file system. You know how they have a mothership in Star Trek or those movies? We used to have those, so the mothership. So this is the mother root files, basically the C drive of your Windows. This is the C drive of Linux. We call it root /. Now, do not confuse this root or slash with a root or a directory called root right here. This one, do not confuse it with that. But you will come to learn in which context we're talking down the road. Now, the point that Signby was bringing up was really beautiful. Now, I am a regular user. So I have my personal space right here inside of /home. This is home. This is where all of you guys are. Everybody has their own little private container where they are creating their own space and stuff. And this is under /. Okay, there's one folder called home. There's another folder called root. Okay, root. Now, me being a regular user called Linoop, do you think can I get out of my actual space, my private space, and try to access this folder right here? Can I do that? Me being a regular citizen, can I just simply walk into White House thinking like this is my own place? This is my house. I'm gonna have to kick out President Trump, and then this is my house. No, it doesn't work like that. But can an elevated user access my space or any other space? Yes, because they have executive authority. They have higher authority. So when you are a root user, this is your home directory, being a root user. Nobody can come into this. Nobody can list this unless you are root or you have, you know, exactly, unless you have elevated privileges or pseudo access as well. We will come to talk about that down the road. But being a root user or somebody who has higher authority, they can actually come and um, you know take a look into other stuff. So what Signby was actually pointing to was that you guys are all inside of this folder. Your containers, your private space is within this fold slash home. This is where you are. Everybody is inside of this folder. This is where your workspace. But there's a workspace called slash root right here. This is where we all work. This is where the administrator or the root user, that's their home directory. Okay. You just be able to distinguish that. Okay. The root user, the administrator resides here. This is their private space. Although all of these can be managed or accessed by the root user, they can do that because they are like the god mode, as they would call them in the games. Root user can do anything on the system, but because we are regular users, we cannot touch, we cannot go into certain directories. Like for instance, we cannot go into root. Then there may be some directories within the var, within right here. There may be some directories we cannot go into those because, again, being a regular citizen, you still have to go to DME to get your license. You cannot simply walk into DME and pull out or steal a license. You still have to go through the whole process. You got to request, you got to beg, you got to provide your credentials. So you can do that as a regular user, but you would require elevated privileges. So just do understand that many times if you do cat slash var log messages, these are system sensitive logs. And me being a regular user, when I will try to access them, permission will be denied. Whenever you see permission denied, folks, what should come to our mind automatically? Permission denied. Do I have the rights to read this? You should always ask yourself whether if I have rights to read this or not. Okay. This very frequently happens to me at home too. When I try to at nighttime. My wife is kind, but sometimes when I try to go overboard and try to eat those extra cakes that, the leftovers, she always tells me permission denied. So we get permission denied. I mean, I love sugar and, my lady is not that sweet. But anyway, so she denies me sugar. So permission denied. So when you don't have that, you got to be careful. And I try to be root at times, but then I don't have root access. I only have pseudo access. Women have the root access at home, and they very well should. Their duty is actually tougher. But anyway, let's come back to Linux. So whenever you see a permission denied error, it should always occur to you that, oh, whether am I doing this as a regular user, or what are the permissions on these files? Can I long list that? I don't know if it's even going to allow me to long list that slash var log messages. Okay, look at that. Who can read and write in this file? Only root can do that. Can the others that basically, I hope you guys already know, the owner. You guys know this information, right? You guys already know this. There are 3 bits for the user, 3 bits for the group, and 3 bits for the other. And they all are turned off. There isn't any permission allocated. So nobody's going to be able to read it except the owner, root, because they have the one read and write permissions. There has to be a list of command that we have read. I think there is something missing at the end of the Linux class. There has to be a list of command that we have read. Sorry, I couldn't comprehend that question. Maybe you can reformat it, please. I will try to answer that. Okay. All right, folks. So let's everybody come back to our space. CD, I am back into our private space. So we know touch command creates a file and mkdir creates a directory. Now, interestingly, what if I wanted to create a directory structure? Meaning, if I wanted to say, create a directory called system, and inside of that directory, I want to create a directory called var, or variables rather. And inside of that, I want to create a directory called logs. Can I use mkdir to create that file, directory rather? Mkdir. I will hit enter. Why is it giving me the error? Well, the reason why it's giving you the error, folks, you need to understand is, first of all, does this log directory exist? I mean, does this variables directory exist in order for logs to be created? Now, if that doesn't exist, obviously, how is it going to create that? Now, does this system directory exist before this variables directory to be created and before logs to be created? So remember, each one of these are dependent on each other because that's what you're asking. This one has to exist before you could create this one. And this one has to exist before you could create this one. That's why it's complaining. He's saying, hey, create a directory called logs, which should be inside of variables, which should be inside of system. And the system is saying, hey, okay, I'm willing to create logs directory for you. But do you have variables existing inside of system? I don't have that. So what can I tell the system? How can I tell the system so that it just follows my lead? It creates it whether if it exists or not. So therefore, I will have to say -p. -p meaning, hey, I know this directory may not exist, but make it a parent directory. And inside of that, create a child directory called variables. And I know this directory may not exist. Make this directory, make it a parent directory to this logs directory. So now this whole structure could be created. So -p stands for parent, meaning the parent-child relationship, meaning this is the parent, variable is the parent to logs, and system is the parent to variables. So P for parent. Make a parent-child directory structure. That's what basically is doing. Okay. I will hit enter. Okay. So do you see the importance of flags, folks? Why do we need flags? Why do we need options? Because it can save you a lot of work. What would have been my choice if I did not use the option -p flag? Had I not known this -p flag, how would I have gone about creating a directory structure called, let's call it like OPT system new users? How would I have created this directory structure if I did not have this P option? Well, in that case, I would have to do mkdir, make the first directory, OPT. Okay. Once that is created, I will do mkdir opt slash the next directory, which is the system, which is going to get created inside of OPT. Inside of that, if I need to create the next mkdir opt slash system, and inside of that, I will create this new directory. Okay. Now what? And then if I do mkdir opt system new, and now I will go ahead and create user. Do you see how this command is extending? It's getting larger and larger. But this is where Linux gave me a beautiful option. He said, hey, why are you going to do that? Why don't you just do mkdir -p and say dir 2/dir 3/dir 4/dir 5 /dir, so on and so forth. So I don't now system is not going to care whether these exist or not. It is going to go ahead and create. All right. Exactly. So it's the word we use is called directory structure. It's like one directory embedded within another, the next one within another, so on and so forth. Okay. Now, folks, I would like to see your understanding. If I removed directory 3, I should still be able to retain directory 4, 5, and 6, right? If I deleted this directory 3, I should still have directory 4 and 5, right? Because I only removed directory 3. Is that a right understanding, folks? How many people would contest that idea? Very good. Why? Why this is not going to work? Because directory 4 is inside of directory 3. Directory 5 is inside of directory 4. Directory 6 is inside of directory 5. So do you see how if you remove the parent directory, all the children, they will be gone. They will be gone. Exactly. So this is exactly what I wanted to emphasize. I want to make sure you guys understood this, that these are not individual directories. They are, they are enfolded. They are within each other. So directory 6 is inside of 5. If you deleted 5, well, you're getting rid of both of these. 5 is inside of 4. If you deleted 4, then 5 and 6 are also going to be gone. And then 4 is inside of 3. If you deleted 3, well, 3 is going to go, but then it's also going to take everything else with it. So, folks, this is exactly what we need to understand. Okay. Same thing with 2. You remove 2, well, guess what? The whole tree is gone. So we need to understand it. I hope this all made sense to you. These are very, very, don't forget to sing first. I will do that. Don't forget to understand, because these are very, very, I know these are very childish, very rudimentary concepts. To some of you, it may make sense immediately in an instance, but for a person like me, I'm a very slow guy, and I move slow, but I eat fast. But what I'm saying is that it takes me time to, digest ideas. But once I comprehend them, then they kind of, they are very difficult to, let go of. So please, we do need to understand this concept. Okay. All right. So today we did that. Then another thing that somebody wanted me to do was, so we created directories and files. Now, one thing I would like to do here is, folks, I want to give you a really fun command, which some of you may be familiar with, some of you may not be. It's called echo. Echo is a command. Basically, what does the word echo stands for? Echo, you say something, it repeats back. So you say echo, let's just say actually, we love Linux. We love Linux. We all love Linux. If you type so this is the command right here. Now, echo command, all it does is whatever you type in front of it, it simply reprints that on the screen. That's all it does. Echo doesn't do anything, but we will manipulate this. So you do echo and hit enter. We love Linux. Echo. We shall prevail. Inshallah. It reiterates that. Echo. Life is worth living. So it is repeating whatever we are typing. Okay. No, text. The text stays small. Yeah, it stays small. Not in. You don't make it larger and smaller in Linux, though. Okay, you can capitalize it. You can lowercase it, but you cannot make it larger or smaller. Obviously, I can zoom in and out myself to make it larger and smaller. Yeah, that's at my own discretion. But in the file, it will not be as larger or smaller. No, it's not like Microsoft Word thing. Okay. All right. So the command is echo. I love Little Debbie's cakes. Okay, that's good stuff. Those of you who know Little Debbie, they're a blessing to American nation. They make beautiful cakes and Entenmann's. Echo, I love Entenmann's. Okay. Now, yeah. So now, folks, so of course, echo is simply printing out what we're doing on the screen. Now, you know how you have there's a pipe, right? Sometimes you want to the flow of the water is in one direction. but you want to twist it. So you put a, you know, what do you call that? The knee. There's usually a knee that you place on it, right? To change the flow of the water. Okay. You are redirecting that flow of the water, right? You are redirecting that. And you're redirecting to some reservoir or whatever that case is. So it's getting stored here. So that the knee is redirecting the water. Elbow. Sorry. Thank you, guys. Elbow. Yes, that's the word. Elbow or the knee. I think that I hurt mostly on my knee, so that's why I'm concerned about knee. But if somebody's elbow is hurting, yes, that's so elbow. So in Linux, when you do echo, I love cakes. I hope you guys love cakes. And there's a knee or elbow in Linux, you call it redirection. These are true greater than signs. They are basically redirecting, folks. Okay, true greater than signs. So you what you're essentially saying is, hey, echo is going to spit out stuff, but you know what? I don't want to see it on the screen as it has done previously. I don't want to see this stuff. Simply send it into a file. Let's call it my-file.txt. Okay. So now if I hit enter, I don't see stuff on the screen anymore. So what I did is using that elbow or that knee or whatever you want to call it, they use it in construction very frequently. In PVC pipes, they use that very frequently. If you were ever to look inside under your sink in your bathroom or somewhere there, you will see some of these. So it's basically redirecting that, it's channelizing that into it. So what it did is that I love cakes that was going to be presented on the screen. Now it has been redirected. It's called, the word is redirect. It redirected into a file now. Well, how do I make sure it's in the file now? How can I read this file? Well, all those commands that you have used. Oh, by the way, when you redirected this, did I have this file existing in my directory before? I didn't. So it created a file as well. So in addition to your touch command, you can use greater than symbols to create a file too. Now I used echo. So there are two things that happened here. One, it redirected that output that I was supposed to, or standard output that I was supposed to see on the screen, into a file. And if this file was non-existent, it would create it for me. So this file is there now. If I do ls, my-file.txt, and now if I read that file, my-file.txt, by the way, folks, if you use cat and if you use my and hit tab, very, very powerful option. I mean, this is from heavens. If you just simply type first few characters, my dash, and hit tab, see what it does for you. Amazing. It is going to auto complete that for you. It is so powerful. And this is what gives me the capability to type things very fast. Okay. Auto completion helps. So if you hit type few characters, first 3 characters, 4 or 5 characters of a file or a directory, and then hit tab, it automatically completes that for you. And now hit enter. Look, the text I love cakes was sent into this file. And when I read that file, it completely shows me that it has it stored in it. Why would we want to use echo over touch? Well, remember, touch only creates a file. Does it allow you to input the content into a file? Are you able to write it through touch? You're not able to write into a file. By the way, echo is not the true way of editing or writing stuff into a file, but this is one of the way we will frequently come to manipulate the files on Linux system. But right now, I just want to give you a taste of how things are going about. But you need to understand this, folks. Now, if I did, now here's another way, folks. If I do ls-l in my current directory, it shows me the stuff on my standard output on my screen. Now, if I do ls-l and redirect that into a file called my-output.txt, what do you think is going to happen here? Am I going to see something on the screen right here, folks? Should I be seeing something on the screen? Well, let's see what happens. If I hit enter, I don't. So what do you think this file should contain? What should it have inside now? what was supposed to be on the screen has been sent into this file. So now when I read this file, my dash out, and I will use the tab to autocomplete that. Look, it has the very thing that I was supposed to be watching on the screen. It's been sent into that file as a content. Do we understand that part, folks? I know this is a little tricky, but it is simple, straightforward. I'm going to go over this again. Let me get echo command. Let me do it one more time. Folks, we have about 2 more minutes and then we're going to stop. Okay. All right. So let's do this, folks. If I do echo and I type my name is James Bond. Okay. I want to send this text. If I hit enter, it's not causing me any harm. It is simply displaying the text on the screen. But if what load average, okay, if I do redirect that into a file called 007.txt, instead of seeing my name is James Bond, it's just going to be simple plain output, nothing on the screen. But this file has been created 007. If I do ls, I do see 007.txt. If I cat it 007.txt and I hit enter, you will see it has that content. Now, folks, another important thing, if I said my name is, oh, sorry, if I do echo replacement, or if I say this is to replace James Bond, or whatever you want to do, just something. And instead of, if I do 007.txt, you know, when you do that and you hit enter, nothing showed up on the screen. So that means I should have 2 lines now, because I had my name is James Bond there, and then now added this is to replace James Bond. Ooh, do you see what just happened here, folks? Did you see what just happened? I accidentally used a single greater than sign rather than 2 greater than signs. Do you see what happened here? It removed my name is James Bond. It removed what already was inside of that file, and it replaced it with this is to replace James Bond. So single greater than sign, it will delete everything that is inside of your file and replace it with what you are providing to it. So, whereas when you use 2 greater than signs, it will append. The word is append. It is going to add at the bottom of a file. Okay, let's try one more time. Echo. Let's send apples into file called fruits.txt. All right, now let's read that file. Cat fruits.txt. You have apples. Now let's send peaches. Echo peaches, using 2 greater than signs inside of fruits.txt, the file that already exists. And now when you read that file, you will have peaches. Now let's go ahead and send berries to fruits.txt. And when you read that file, you have 3 items: apples, peaches, berries. But now all of a sudden somebody says, let's send, what can we do? Send watermelon. Actually, let's send pizza. Folks, you can clearly see I eat a lot of junk food. And use single greater than sign and send it to fruits.txt. And you hit enter. And when you read that file, cat fruits.txt, it deleted my apples, it deleted peaches and berries, and it replaced it with pizza. So single greater than sign. Yes, right now we are joking. Right now we are enjoying, we're having fun because we are in test environments. Folks, imagine you guys were in an organization where there is a microsecond of tweaking that is needed. There are files that are so sensitive that are performing transactions that are helping the system or applications perform transactions of millions of dollars, hundreds of thousands of dollars per second or per minute. And we end up using single greater than sign and sending something to that or some configuration to that very important file, and we end up wiping that out. Do you know what type of damage you can cause? It is going to go ahead and, I mean, it's a remedy for destruction. I mean, yes, we will come to use this in certain occasions where things aren't mission critical, but most of the times you will get to use two greater than signs. Please- now, Waramo. Yes, I love pizza, folks. Folks, it's top of the hour. I'm going to stop here. I'm not going to carry this on. So today's just for revisit, the things that we've done is cat to read a file, more, less, head, tail. This was to read a file. Then we did touch, and then we did mkdir, and then we also did echo. We used echo, and within echo we used single two greater than signs to append or add, and then we use single greater than sign to override. What's the word? Override. Delete pre-existing content. All right. So you got to be careful when you use this. Okay. Right now we're in a test and lab environment. So everything is very, we could break it. It's okay. We can rebuild it. But when you will be in that Fortune 500 company where they're going to be really, really relying on you to edit files that potentially can cause either or help them either, improve the performance of the system or completely destroy it. That's where your fingers will tremble. That's where you're going to be sweating. That's where you're going to have to take that handkerchief that your uncle from Italy gave you as a, that the one that you usually carry in your pocket. Who the hell carries handkerchief nowadays? Nobody. Sorry. Who the heck? Sorry. I apologize for if there are kids around you. Folks, my kids, they have kept me so grounded. Like if I utter a word that is, kind of out of line, they tell me, Daddy, what's the matter with you? So kids are the fathers of the elders. Okay. So what we need to do is we need to be very careful. Okay. But this is exactly your playground. This is where you practice. Okay. So meanwhile, session is, ending.